So we are given the problem to integrate the definite integral from 0 to pi over 3 of sine 2x times sine x. So if we just look at this integral, we can see that there is a 2x inside of this sign and a singular x inside of this sign. So integration by substitution is probably not going to work. But if we look at this first term over here, recalling our trigonometric identities, we remember that sine 2x is equal to 2 sine x cosine x. So if we substitute this right-hand side into this term, then we have everything in terms of sine singular x's and cosine singular x's. So let's do that. We have the integral from 0 to pi over 3. That stays the same. And this just becomes 2 sine x cosine x. And we still have this sine x from before. So we have sine x dx. So if we simplify this, then we get this definite integral of 2 sine squared x cosine x dx. And now we can see that we have sine in some sort of power, and we have a single cosine x. So now we can use substitution, because the derivative of sine x is cosine x. So let's give that a try. We have u is equal to sine x, and let's have du equal to cosine x dx. So now we can rewrite our integral in terms of u. So we have cosine x dx be replaced by du, and we can have sine x be replaced by u. And now our upper and lower bounds of integration are going to change as well. So our lower bound of integration is going to be sine of 0. So our lower bound is going to stay the same. And our upper bound is going to be sine of pi over 3. Well, what is sine pi over 3? So pi over 3 radians is going to be the side length, or the angle of angle between two sides of an equilateral triangle. So pretend that this is an equilateral triangle, then it's going to be this angle here. So that's pi over 3. So if this is an equilateral triangle of each side length being 2, and this is going to be 1, and by the Pythagorean theorem, this length is going to be 2 squared minus 1 squared, so it's going to be 3, and it's going to be the square root of that. So this side length here is root 3. So sine of pi over 3 is opposite over hypotenuse, so it's root 3 over 2. So sine of pi over 3 is the square root of 3 over 2. So these are our new lower and upper bounds in terms of u. So now let's just substitute u for x. So we have 2u squared du. And now we can compute our definite integral by taking antiderivatives. So the antiderivative of 2u squared, well, that's just going to be 2 over 3 u cubed, and this is going to be evaluated at root 3 over 2 and at 0. So what this is going to equal is 2 over 3, and this is going to be root 3 over 2, all cubed, minus 2 over 3, 0 cubed. So that's just 0. Minus 0 doesn't do anything to our final answer. So this is our answer. So if we simplify this, then what we get is 2 over 3, the square root of 3 cubed over 8. And two of these 3's can come out as 1 3. So what we're going to get is 2 over 3, 3 root 3 over 8. So 2 over 8, well, that's just 1 over 4. And these 3's can all cancel out. So what we get as our final answer for this definite integral is root 3 over 4.